welcome to class number 27. We are going to identify and quantify force of static friction and find the force needed to start moving an object. So this first one is asking you to find the normal force. So let's do this two ways. Let's do this one by using a free body diagram and one just using some concept knowledge. So here's our free body diagram. We have negative Fg going down, that's the weight, and we have normal force going up. All right, so we have acceleration equals F net over m. All right, so the acceleration in the y direction, up and down, it's not accelerating at all, is 0. F net is going to be normal force minus Fg. Remember, Fg is just mg, right? Hopefully you remember that. So, all right, plus negative mg. Okay, hopefully you know why I made that substitution. I'll multiply both sides by m. Okay, so that goes away. So we have normal force equals mg. So normal force equals the weight. M is 15 here, so mg is going to 15 times 9.8, I think is going to be 147 newtons. All right? That's like the technical, most correct way to do this question. The other way is just think of it conceptually. Are we on a flat surface? We have three questions to ask ourselves. Are we on a flat surface? Yes. Is this thing accelerating up or down? No. Is there a third force in the y direction? No. Therefore, we know that normal force is equal to mg. Ask yourself those three questions, though. You have to be able to answer all of them, or you can't do this. Because like I said, usually normal force is equal to weight, but not always. All right. When I push on a book and it does not move, this is static friction. When it does move, this is kinetic friction. Okay, static obviously means stationary. Kinetic means moving, but most specifically here, I think sliding is a better way to put it. So if student pushes on a box that won't move, that's static. Skis sliding, that's kinetic. Hands rubbing, that's kinetic. These are coefficients of friction. These are on the reference table. But do realize these coefficients of friction are only determined by the materials that we're dealing with. It is not dependent on the mass of it or anything else, the normal force, none of that. Again, this is just a coefficient of friction. This is not the force of friction, okay? This just tells you basically, it's a ratio number. We'll see it in a bit, but basically how much friction there is between different surfaces. But again, it's not a force, it's just a relationship. All right, so let's look at this question here. A student pushes on a box with a force of 10 newtons and it does not move. The force of static friction is blank. So here's my box that doesn't move. We have negative force of gravity. We have normal force. We have 10 newtons going forward. And we have friction going backwards. So let's do this the technical correct way. So we can only work with either the x or the y direction. We can't do both simultaneously, all right? So let's look at the y direction. In the y direction, we know that the acceleration in the y direction is equal to F net in the y direction over the mass. So the forces in the y direction are normal force and force of gravity. The acceleration in the y direction is 0. The net force in the y direction is normal force minus Fg and over the mass. So I know that the normal force is equal to Fg. I don't actually need to know that for this question. It's just nice to do. Let's go in the x direction. Ax equals F net x over m. So acceleration in the x direction is 0. F net x is going to be my two forces in the x direction, the horizontal direction, so 10 newtons minus force of friction all over mass. So I end up getting that the force of friction is equal to 10 newtons. That should kind of make sense to you. If an object is stationary, not moving at all, if 10 newtons is pushing it forward and it's not moving at all, 10 newtons must be holding it back. The next one is effectively identical in every way, but instead of 10, we have 30. So I'll leave that for you to do on your own. All right, so when an object is stationary, the force of friction always matches the applied force, like we just saw. If I'm pushing with 10, it's 10. If I'm pushing with 30, it's 30. The force of static friction is always equal to the applied force until a certain point, until it begins to move, until you apply enough force to move it. How much force do you need to move it? This much force, okay? The coefficient of static friction times the normal force. Once you apply that much force, this thing's going to start moving. Then it becomes kinetic. So for static friction, this equation tells you the minimum force that must be applied to start moving an object. We were using the phrase a lot, threshold. It's kind of like that threshold of motion, okay? So since it's really the threshold, technically the equation is written like this. Force of static friction is less than or equal to the coefficient of static friction times the normal force, meaning the force of static friction could be much, much smaller than this number. This number here tells you when it starts to move. Until, you can push it with as much force as you want, but until you reach this number, it is not moving, and the force of static friction will equal the applied force. All right, we actually did this in Lab 9, which is definitely way better to do before we did this class. This is, static friction matching the applied force. This is the threshold of motion. That's where this equation comes into play. It's equal to that point right there. Then we have kinetic friction, okay, which we notice is a constant. So according to the graph, how is force of static friction different than force of kinetic friction? Force of static friction equals applied force until it moves. And force of kinetic friction, so when does it begin to move, by the way? It begins to move when force of static friction equals mu normal force. All right. So the force of kinetic friction is a constant number, which makes those calculations way easier. All right, this is doing a simulation. I don't even know the answers to this, honestly, or don't remember them. But the first thing we did in the simulation, let's see, we drew a box the instant before it began to move. Actually, I think I remember a lot of the numbers here. Okay, so we had weight going down, that was negative Fg. We had normal force going up. Okay. It was like the moment before it began to move, I think it was 250 newtons. I hope I'm right here. And the only thing stopping it from moving, again, the instant before it begins to move, is the negative force of friction, right? So, it says include values of friction. Oh yeah, the frictional force I think was equal to 250 in this case, so I'll write negative 250. The force of gravity, I think it was 50 kilograms. So that's equal to 50 times 9.8. I'll see if I have a calculator handy. $490, I should have known that. Okay. So what's the normal force acting on the box? Explain your answer. The normal force here is equal to Fg, so it's equal to 490 newtons. Why? A few reasons. You could do the whole math thing. We did that up top. We did it right in number 5 to show that normal force is equal to Fg. It's basically the same idea. Or you just say to yourself, is this a flat surface? Yes. Is there another force acting in the y direction besides normal force and gravity? No. Is it accelerating up or down? No. So we know it's equal. How much force is required to start moving the box? I think it was 251 newtons. So find the coefficient of static friction. So we're going to use this formula. Fs equals mu s times the normal force. Force of static friction. So you have to use this number here, that threshold number. So this is 251 newtons equals mu times the normal force, which is 490 newtons. Divide both sides by 490 newtons. Now, a lot of people ask the question here, what are the units? I'm glad you're thinking about units. Well, what happens here is that we have newtons divided by newtons, so mu s is actually a unitless quantity, one of the few we'll have this year. 0.51 is what it comes out to be. Was the force of static friction the same throughout the activity? No. No. Force of static friction equals applied force until it moves. In this case, that was 251 newtons. That's obviously going to be different for every scenario. So why isn't the force of static friction equal to the force equal to that number all the time? Well, again, that's basically explained there. Once the object begins to move, what happens to the force of friction? It drops to 188. Okay, 188 newtons. That was kinetic, right? When things are moving, it's no longer static friction. So to take more force to start moving something or to keep moving it to start. Why? It was 251 newtons to start moving it. Okay, and it's greater than the 188 newtons that are required to keep moving it. This question we do at a later time, so you don't have to do it right now. All right. Have a great day, everybody. Let me know if you have questions.